Hi guys. Today we're going to learn a different way to write an equation for a parabola. So we're still graphing a parabola. We're still going to answer all of those questions about the parabola, but the original format of the equation will be different. Today's format is called vertex form. Now, as a reminder, what we've been doing for the past 2 days is called standard form. And this one, maybe you've even seen before. Standard form was an Algebra 1 concept as well. But vertex form is going to be completely new. So here is what vertex form looks like. You'll notice they have some similarities. They both are y equals. They also both have a letter A in front of the x. And that letter A means the same thing in both of these equations. So we learned earlier this week, when A is positive, it's up. When A is negative, it's down. That still applies with this letter A. And so you can use that for the same thing that we were doing earlier this week. The things that are new is in vertex form, I now have an H and a K. The H and the K are referring to the vertex. That's why we call it vertex form, because the actual numbers for the vertex are right in the equation. Now we have to be a little bit careful. The H is being subtracted in the original equation, which means that when you're taking it and putting it in your ordered pair, you're going to need to do the opposite sign. And I'll show you a little trick to help you with that as well if you can't remember to do that. So in theory, in vertex form, we'll be able to just stare at the equation and find our vertex. That means we don't have to do any work on these problems, because the only work we did have to do was solving for the axis of symmetry in the vertex, and now we don't have to do that. So these problems, I hope you will find them a little bit nicer than standard form. Before we do our graphing example for today, let's practice a little bit finding the vertex. So in this equation, this is in vertex form. I can tell because of the parentheses squared. And if I want to find the vertex, I'm going to take the opposite of the number with the x, so positive 3, and then I'm going to take the number that's being added at the end, so positive 7. And so my vertex for this problem is positive 3 and positive 7. Now, a trick to help you get the right sign for the x number is you could take the parentheses and set it equal to 0 and then solve for x. So when I do that, I get x equals positive 3. So that can also help you figure out what the sign is for your x coordinate. And then the y coordinate, you just keep the same sign. Now, the cool thing about doing this little trick also is that this is your axis of symmetry, x equals 3. So that'll also help you with that. Just a little side note, the only number we did not use is the number 2, and that's your A. So remember, the 2 tells us that this is opening up. It has a minimum, and it's going to be a skinny parabola since it's larger than 1. Here's one more example. Now, this one technically is written in both standard form and vertex form, but we're going to pretend like it's vertex form for this problem. So if there are no parentheses in vertex form, you can put parentheses in there, and you're just going to put a 0 inside of it. So I can rewrite this with an x minus 0 in parentheses. And if there's no adding or subtracting at the end, just add a 0 at the end. So sometimes pieces will be missing. That's okay. You can put them in. Just put in a number 0. So if there's no parentheses, put a parentheses with the 0. And if there's nothing being added at the end, add a 0 at the end. That means that my vertex for this one is at 0, 0. And then don't forget this front number is your letter A. All right, so now we're to the point where you can be using the worksheet flowchart that you had printed out. So this is our first example to go across the flowchart. We're going to go in the same order that we went yesterday. So we're going to start by finding our axis of symmetry. Now don't forget, I just showed you that little trick on how to find it. So we take the inside of the parentheses, and we set it equal to 0, and then we solve. So my axis of symmetry for this problem is x equals negative 3. That negative 3 is also used in the vertex, and then the other number for the vertex is just this number at the end of the problem, the negative 4. Negative 3, negative 4. In this problem, my letter A in front of my parentheses is the number 1. since there was no number there. And since that's positive, it's going to be opening up and have a minimum. My domain is all real numbers. My range, since it's opening up, is greater than or equal to, and then we take the -4 from the vertex. Now, unlike our standard form problems, we'll need to graph before we can find any of our intercepts. So right now, I'm going to go ahead and skip to graphing. So I can graph my axis of symmetry, my dotted line, through the -3. And I can graph my vertex at the -3, -4. We're going to use the same special ordered pairs that we used for standard form, because it's still a parabola. And in this problem, since my A is 1, my special ordered pairs will not change. So I will do 1, 1. So starting on the vertex, right 1, up 1, and reflect. Next, we have 2, 4. So starting on the vertex, right 2, up 4, and reflect. And then I can fit 3, 9 on here as well. So starting at my vertex, right 3, up 9, from the vertex, right? So not at the actual number 9, and reflect. And here's my parabola. Now we're going to go back and we're going to find our intercepts based on what the parabola looks like. So the first intercept we usually ask for is the y-intercept. And the y-intercept is where it touches the y-axis, which is right here. So we do want to count because we went up 9 from the vertex, but that's not actually at the number 9. So that's at 1, 2, 3, 4, 5. So my y-intercept is 0, 5. And then this example has 2 x-intercepts. So one of them is right here at the -1. And then the other one is over here. And that's 1, 2, 3, 4, -5. So my 2 x-intercepts are at -5 and then at -1. Make sure you write them as 2 separate ordered pairs because they are 2 separate dots on the graph. Okay, so we just did a whole problem with like no work at all. So vertex form, you don't have to show me any work. You can just instantly write down the answers. This is the end of our first video. And in the second video, we'll find out that sometimes you do actually have to do a little work. So I'll see you in a minute.